Have you wondered how cells that no longer perform their functions exist in your body? Like this basketball. What a waste! There are cells with a bipartite phenotype that escape death, multiply, and cause diseases that come up to the midpoint of your life. 1960s, the scientists Hayflick and Moorhead found out when a stem cell can no longer divide, they have lost their telomeres, their chromosome endings. They came up with the Hayflick limit that states that a normal human cell can divide up to 50 times, meaning that a senescent cell has already completed them all. So, what next? For cell senescence to happen, its causes combine, such as epigenetic changes, DNA damage, and the rest. There is a process, DDR, which constantly happens in senescent cells, where it tries to sort out all the issues of the DNA. But for senescent cells, DNA damage is repetitive, and so kinases take over to fix standbreaks and something known as replicative stress. Kinases ATM and ATR are the next step before a response is carried out, such as repairing that DNA. So cell division is considered ended. Senescent cells release a mixture known as SASP, which temporarily benefits the body, but then inflames it and causes cancer. Just like any internal problem, they have their own biomarkers, beta-galactosidase and P16-INK4A. But this isn't even unique. Other cells have it too. And so, a doctor might target a healthy cell rather than a senescent cell. But there are in the name of senolytics, drugs which provide a therapy for senescent cells. An example of a natural senotherapeutic is phycin in your mangoes and in your apples, or quercetin found in your onions. But their use only removes a handful of senescent cells in two at the same time. Research says it's more beneficial. But in the long term, we can't rely on drugs. So scientists are balancing things out, trying to keep the good and eliminate the bad. What would you do?